Okay, so if you look at 1b, it is 2x minus 3y plus z equal 12. If I'm going to graph this, I'm used to having a two-dimensional Cartesian coordinate system, right? It's got an x-axis and it's got a y-axis. Since this has got three variables in it, it's got three axes in it, which is what makes this 3D. And I'm sure there are tons of nice little programs online that'll graph this, but I'm just going to do my best with my 2D technology here. I'm going to go ahead and label my axis. And one of the things I noticed on the test, and most of you guys did a good job of this, or a few of you that need to make sure you always label your axis and you always put your scale in, because I don't know what you're counting by. And that actually came into a problem on the test because some people chose to do a graph a different way than was intended, and so they ended up with going off the scale I used. And okay, so if I put my marks on here, I'm going to go ahead and I'm just going to go ahead and try to do the best I can to make a 3D graph here. All right. I'm going to try to put marks on each side. I'm going to count by ones here. And so what I should do on my paper is go 1, 2, 3. On each axis, at least show that I'm counting by ones, 1, 2, 3. Okay. Otherwise, people don't know what you're counting by, and most teachers would count a problem completely wrong if you didn't put some numbers to show each axis what you're counting by. I have not done that, but I'm going to have to toughen up because I had a grading nightmare with some tests trying to grade the graphs when they weren't marked. Now, here's the thing. When I had standard form, do you remember how we could find the x-intercept? If I have like 2x plus 3y is 12, for instance. I could set x equal to 0 and find the y-intercept real easily. Do you remember doing that? You actually had one on your test. And I could find the y-intercept by setting, x equals 0 would give me the y-intercept. If I set y equal to 0, it would give me the x-intercept. That allowed me to get 2 points and graph it. I might not have the slope right in front of my face, but I could count it off the graph. And I might not know what the y-intercept is, but, oh yeah, I do know what the y-intercept is because that's part of what we did, right? We're going to kind of use the same idea here. This is not solved for y, and I probably don't want it solved for y, because what do you do when there's three variables? If you're trying to graph an equation that's a three-dimensional one, it's really easiest to do this whole idea of we're going to find the x-intercept, we're going to find the y-intercept, and we have a new variable. We've got to find its intercept too. Find the z-intercept. The z-intercept would just be where is this graph crossing the z-axis, which I've drawn in. It's kind of representing in this graph, if you think about it, your x is your horizontal, your y is your vertical, and that z-axis is kind of giving you the depth perspective of this 3D equation, if you want to think of it that way. Okay, so how do I do that? How do I find the x-intercept? The old way we found the x-intercept when we just had an x and a y in the equation was set the opposite variable equal to 0. We're going to do the same thing here. If I want to find the x-intercept, I'm going to leave the x in the equation, but I'm going to set y and z equal to 0. Okay? So that goes to 0, and that's 0. So don't I end up with simply 2x equal 12? Okay? So it would be x is 6. If you divide both sides by 2, x is 6. Okay, so on the x-axis I have a x-intercept of 6. I'm going to graph it in green. 1, 2, 3, 4, 5, 6. That would be right here. I almost didn't make it big enough. Oh, I didn't make it big enough for the z-axis. Oh well, such is life. Okay, we'll just deal with it when we get there. Let's do. Now that's my x-intercept. Let me find my y-intercept. My y-intercept I will set the other two variables equal to 0. So that's going to be what, x and z. Okay, so x is 0. I don't set y equal to 0 because I want to know what it is, and z is 0, and they're equal to 12 when we add them together. So 0 minus 3y plus 0 equal to 12. Well, that's just minus 3y is equal to 12, right? If I want to get the y by itself, I divide by negative 3. So what's my y-intercept here? 12 divided by negative 3 is negative 4, right? So on the y-axis, I want to to graph my y-intercept by going down to -4. Here's -1, -2, -3. I didn't make a slash for -4, but I will now, and I'll graph it in purple. It's down there kind of in the arrow, isn't it? On the y-axis at the bottom, if you don't see it. So what's left to graph? The z-axis. I'm going to choose like a brownish color, orangey brown. All right, this is the one I'm going to have a problem with. 2x minus 3y plus z is 12. And can anybody tell me why I'm going to have a problem with this? I want the z-intercept. I'm going to set what equal to 0? Z is 12. I said x and y equal to 0. So she's seeing it, but I'm going to go ahead and do it. Set x equal to 0, set y equal to 0, and plus z equal 12. The problem is, okay, that becomes 0 minus 0 plus z equal 12, so z is 12. You know, really, if you just cover up the other terms that you set equal to 0, you pretty much get the equation really quickly, don't you? You could actually use your finger to cover it up and see it. How am I going to graph z is 12 on this iPad? With my graph I drew, am I going to be able to go out to 12? Let's pretend that 12 is right here, okay, just because I don't know what to do. I don't have a big enough graph, and you know, I'd have to start over, which means the video would be kaput. Let's say 12 is here. I know that's not where it really is because that's not how, you know, the spaces go, but pretend it is for a minute. If I want to show this three-dimensional, what we're going to get is a plane out of this answer, because it's, if we only had 2 dimensions, we'd get a line. If you have 3 dimensions, you get a plane, because planes would be what would happen when I connect this. If I go connect all this, and I'm going to do it in yellow. Let me do it in a brighter yellow than that. Oh, that's the only one I get. Okay, never mind. If I connect these into lines here, and I were to shade it in, that would represent the plane that equation represents. It doesn't represent a line, it represents a plane. So I could color it in, and that's the 3-dimension, that's the plane that I would be talking about here. If you think about a 3D object, you could take a plane, or think about taking a sheet of paper. What if you could take a basketball and you could slide the sheet of paper through a basketball? Wouldn't it be a flat surface that you would get out if you could actually cut that piece out and look at it? That's what this triangle is representing here, is that flat piece. We're just shaping it like a triangle because we use 3 points to find it, but it actually represents a whole flat surface that goes on and on forever.